While everyone was watching Tesla's Optimus robot dominate headlines, a far more consequential story was quietly unfolding in the open-source AI tooling ecosystem. In just 2 weeks, 5 major package ecosystems were compromised: Trivy, LiteLLM, GitHub Actions, Docker Hub, NPM, and OpenVSX. This wasn't random vandalism. It was a calculated surgical attack on the infrastructure that modern AI development depends on every single day. TeamPCP didn't stumble into Trivy by accident. They chose it with precision. Trivy is a security scanning tool that LiteLLM used inside its continuous integration pipeline. By compromising the scanner first, attackers gained credentials that unlocked the AI library itself. It's the equivalent of poisoning the water treatment plant to contaminate the entire city supply. The irony is brutal. The security product became the attack vector. What makes this attack technically terrifying is the execution model. The poisoned PyPI package contained code that ran automatically the moment the package landed on disk, before any developer imported it, before any function was called. It was uploaded with no GitHub source, no release tag, and zero code review. This is a class of threat that most dependency scanners aren't even looking for, because they assume malicious code needs to be explicitly invoked. That assumption is now dangerously obsolete. The only reason this attack didn't silently exfiltrate credentials from thousands of companies is that the malware crashed machines. A developer noticed RAM usage spiking and started investigating. They traced the issue back to LiteLLM, which had been pulled in as a dependency of a Cursor MCP plugin nobody on the team even knew was installed. Think about what that means. An unknown plugin, pulling an unknown dependency, running unknown code. That is the actual state of AI development toolchains right now. The malware's payload operated in 3 distinct stages. First, harvest everything: SSH keys, cloud provider tokens, Kubernetes secrets, cryptocurrency wallets, and every .in file on the machine. Second, deploy privileged containers across every available node in the network. Third, install a persistent backdoor to maintain access long after detection. This wasn't smash and grab. It was designed for long-term silent occupation of your infrastructure. And the attackers publicly announced on Telegram that security tools and open-source projects will continue to be targeted for months to come. Every AI agent, copilot, and internal developer tool shipped in the past year runs on hundreds of packages built by individuals and small teams with minimal security review. The uncomfortable truth is that most engineering organizations audit their own code rigorously, but treat transitive dependencies as implicitly trusted. That gap is precisely what TeamPCP exploited. LiteLLM holds API keys for OpenAI, Anthropic, Google, and Amazon. Essentially every AI service your organization has ever configured. One poisoned package becomes a master key for your entire AI infrastructure. If you are running LiteLLM in any environment, production, staging, local development, audit your dependency tree right now. Check every MCP plugin that is installed across your team's machines, because plugins are the new shadow IT. Rotate any credentials you cannot fully trace back to a known verified installation point. Start monitoring for PyPI packages that have no linked source repository and no release tags. Those are red flags that should trigger immediate review. The sloppy malware gave you a warning. Treat it as one. The broader lesson from this incident extends far beyond LiteLLM or Trivy. The open source ecosystem that powers the entire AI development wave, from local copilots to enterprise agents, was built on a foundation of implicit trust that sophisticated attackers are now systematically dismantling. The industry needs cryptographic signing for package uploads, mandatory source provenance verification, and automated monitoring for unsigned or sourceless releases to become table stakes, not optional best practices. The attack surface is no longer just your code. It is everything your code has ever touched.